Okay, so we had a look at a few of these already. I think we left off at like question 7 here last time with the sequence of exponentials there. Let's see, what else can we have a look at? Try something like question 11 here. Okay. Cost price $2 per item. Number of items sold per month is given by that equation. P is the sell price. Figure out what P would be best to maximize total monthly profit. We're at question 11 for Kyan, just in case you didn't hear what we're up to.
Sorry, what was that, Chris?
I was just saying we're up to question 11 here, which is what we're focusing on, just in case you didn't hear the beginning.
Yeah. Thanks.
Any thoughts at all as to how we might start? We got a... Oh yeah, go ahead.
Yeah. So $2 per item, so I'm assuming it's 2x of something.
How do you mean, sorry? So $2 per item and what, sorry?
If items, let item be X, then so 2x, $2 per item.
Yeah, okay, fair enough. So you got this cost that is proportional to the number of items that you have. Yep, sure.
Here, okay, so P is price.
Yep, that's the price we're
So
selling
profit,
for.
I guess, would be something minus the price.
Yeah, absolutely. So our profit equation, P, is always going to be how much you're selling for. So that's our little p, minus the cost of the item. So if P dollars is the selling price of each item specifically, and the cost price is $2 per item, what we find is we don't actually need to necessarily have an equation, like an X in there. We don't really need to look at like, we don't need to track it across all different units, because both the P and the $2 is already per item, as is. So our profit, I guess we'll call that P sub R, profit, is going to be the sell price minus 2. Right, and this equation, rather than scaling for all, we're not scaling it for all possible items right now, but this is just on an item per by item basis. Because if we look at what's actually being asked to do, the number of items sold is already going to be handled by this equation here. So we don't need to introduce our own way of doing it just yet anyway. Cool so far? So that'll be on like a unit by unit basis right here, our profit per unit. As far as what we're heading towards, we're trying to maximize total monthly profit. So as of now, we've currently got the profit per unit. If we wanted to convert this into a profit per month, which is what we're sort of aiming towards, there's some other information in the question that can help us do that. Some other numerical information. We've used the $2 thing so far, and we've used P as far as the sell price. Still got this 800 over P squared here. Number of items sold per month is going to be 800 over P squared. How can we potentially be integrating that into our equations?
The 800 of P squared, that's the number of items sold, right?
Yep.
So I guess we can do like 2 times that, so 800 over P squared times 2. So that's going to be the total cost.
Yeah.
Yeah.
That'll update our cost from a per unit to a per month. Yeah, sure.
Yeah.
So our cost is now 2 times that. So 2 times 800 over P squared. Sure.
And the profit is just cost minus selling price.
Correct. Yeah. So how do we need to now update it?
Wait, no, I'd say the other way around.
I know what you meant. Yeah.
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 Yeah. So minus, wait, no, P minus that.
P minus. So P minus this new one now. Yeah.
Yeah.
Okay. Double check the definition of P.
So it's the selling price of each item.
Yeah, of each item. So
yeah, okay. So selling price of each item. So per month, we have to multiply it by 800 over P squared.
Exactly. So it ended up being the case that both of those needed that multiplier, not just the cost one.
Yeah.
800 over P squared.
That's good.
And that way we can.
This is going to be oh yeah, okay. Yeah.
Yeah, you can expand that through or whatever, but this is tech active, so as soon as you have your equation, all you're going to do there is, I guess, do whatever you need to in order to get the maximal monthly profit here. So you can graph, you can Fmax, there's a lot of different ways you can go from there. So let's have a look. Let's see here. So defining our function, x take 2 bracket times 800 on x squared, and yeah, I want to find the value of P for which we get maximum total profit, so it's going to be an Fmax. Fmax h of x comma x, and that just means our little p would be 4 there. Notably, we didn't need to find the actual profit that would achieve. It's just the p value that gets that monthly profit. So for this one, we're going to end up with a p equals 4 here. If it did ask, and what is the total monthly profit for that price, obviously now we're just going to shove that into our profit equation. And that's going to get us $100 per month there in profit, which seems kind of low for these kinds of questions. But anyway, that's the idea. All good with that?
Yep.
Yeah, these can be kind of weird depending on how they're worded. The pricing and like businessy sort of stuff, because the way they can word the information there could be, as we've seen, it could be a per item thing, could be a per month thing. The units are going to matter quite a bit. In fact, probably we should have also had a unit on that P as well, rather than just saying P equals 4. You say P equals $4 specifically. So units are going to matter, and also what those units, what time span those units are supposed to run across, whether it's the per month or per item or however. Cool. Okay, that's kind of whatever. I think those are kind of whatever as well. If you see anything on the page that you wanted to have a look at, anyone, let me know. For now, I think question 14 will be the next one that might be challenging. But you know, you guys are the ones doing the SAC soon, so, well, now almost. So if there's anything specific you wanted to have a look at, I'm more than happy to divert there. Otherwise, question 14. I'm just getting a picture down so we can reference a picture. Because you know, when you've got a lot of worded information there, it's hard to conceptualize that all in our brain. So I'm doing my best to try and put a visual to what this actually is. Okay, I think I got a visual of what's going on. So basically we are starting on an island, point A here. We're rowing towards point B, and then we're, I don't know, walking, driving towards part C. That's the idea of what's happening here. I haven't put all the information in there just yet, namely the speeds at which those can happen. And our goal is to figure out how far along the shore from B towards C should be landed. That's interesting. So for instance, like one possible route could be you go vertically down from A and then perfectly to a horizontal to C. Or perhaps you can cut the angle a little bit less and then go to C from there. Cut the angle a little bit more, so on and so forth. And the idea is to figure out where should we specifically land in this interval from B to C such that we minimize the time taken. It's a challenging question. One thing I'd probably get you to focus on would be the fact that we're trying to minimize time here. So we've got distance information, we've got speed information, and the thing we're trying to do is minimize time. One of the first things we can remind ourselves of is how those variables relate to each other. So speed being distance over time. So we're trying to get time as the subject of which we're trying to minimize. If we do a bit of a rearrange, time now becomes your distance over speed. Okay. Now that's just generic, right? That's for any given scenario with linear, with constant motion. What we got to start doing is figuring out how we're going to put it in the context of our question. So we need distance information and we need speed information. We have both, right? We have the distance from A to B and we have the distance from B to C. And we have the speeds at which can be done rowing and the speed at which can be done walking. So like this is all water and this is your land. So whatever travels in this direction is on water, and whatever you end up at horizontally, whatever you add up on this horizontal line is going to be what your walking speed is. So let's just hypothetically put a spot somewhere, alright? Let's pretend it's here, alright? It could be anywhere along this line. We're just going to put an initial spot in there, just to say that we're going to be somewhere in that line. What do we need to know further to start getting a clearer picture of what's going on? Having this.
Sorry, Chris, I just disconnected from the meeting.
Oh.
Minutes. What are we on right now?
So we're on question 14 here. What I've done is I basically put down as much of the information in there. Well, I'll put down the distance related information and drawn a little picture of what's going on. So basically we have a dude on an island. He's going to row to shore and then go wherever he ends up landing on shore. He's going to then walk towards sea. Now the idea is to figure out, based on the speeds that we have, where should he, along this continuum of V to C, where should he land such that we're minimizing time? Like for instance, if we do here, it's going to be the full 5 kilometers per hour for a total of 12 kilometers, and then the 8 kilometers per hour walk from there for 30 kilometers. Alternatively, he could do the same speed over a new distance, and then this new speed over a new distance. And we're trying to figure out which of these would get there quicker. How far should we, should we swim the least and walk the most? Should we swim the entire duration, or should we do something in between?
So like at what point of the shore he should try and land on?
Yeah, correct. We're trying to minimize the time it would take to get our full journey to sea. So far what I was describing was, because we have distance and speed related information and we're trying to solve for time, it's a good place to start with our speed equation, speed being distance over time. And because it's time that we're trying to optimize for, I've just rearranged to get that time on its own. I've also put in some initial possible position that the dude might land in. Doesn't really matter how shallow or how steep you draw this, because it's all going to be relative to some just some location. Maybe another good thing would be to start getting an axis going. So if we take like maybe point B as the origin 0, 0, now we can start putting some actual numbers together. Like this would be 12 in the y-axis, this would be 30 in the x-axis. So for instance, wherever this spot is, x, is going to be somewhere between 0 and 30, right? More specifically, we could even start identifying that this is a triangle, right? And so if we start saying, well, okay, this is going to be some kind of triangle, I have this length. I don't necessarily have this length right now, but I could get it based on this variable and this total length, right? So if 30 kilometers is the whole thing, and this is at some x location in between that, then whatever's from here to here is going to be 30 minus x. Sorry, that's just x, and then the other one's 30 minus x. Got that back to front. So this distance from here to here is x, and then this distance from here to here would now be 30 minus x. We have this distance, we have this distance. We can now get our hypotenuse, should we want it. Which is just going to be trig, right? So a squared plus b squared equals c squared, or just the rearranged version of that. C is equal to the square root a squared plus b squared. So for us, we're now going to end up with this is going to be the square root of 12 squared, so 144, plus the x squared. So we now know this distance, whatever would be taken along that diagonal. And the good news is it doesn't matter where we've drawn this because it's all relative to x. It's all relative to where that ends up being. Having done that, we now have a distance map for the entire journey. Right? We initially take whatever this distance is, and then we take whatever this distance is. We have the full distance portion of that journey. Now yes, that will change with x, but that's kind of the whole point, right? We need to have a variable of x in there so we figure out where we're actually landing. So when it comes to our time equation, well, I guess maybe I should just do the distance part actually. So the first distance there, d1, is the root 144 plus x squared. The second part of the journey, d2, is just the 30 minus x. That gets us this bit all sorted, the d. Next up is the speeds for those journeys. That one should be a bit easier. How are we going to get speeds involved here? I haven't written them on the page, by the way. They're back in the textbook. We can row our boat at 5 kilometers per hour and we can walk at 8 kilometers per hour. So when it comes to doing our speed 1 and speed 2, what are those going to end up being? Speed 1 being the first portion of the journey, and speed 2 being the second portion of the journey.
Do we just divide it?
Yeah.
Divide the distance with the speed?
Yeah, you're right. So when we go ahead and put that into our time equation, we're going to do the division of each of these distances with their relevant speeds. So I've just gone ahead and split them up so that it's more clear as to where things are going. But yeah, ultimately they will be going back into this time equation. But yeah, so if rowing the boat is 5 kilometers per hour, and that's the first part of the journey, then speed 1 is going to be 5. Exact same logic for the 8 kilometers per hour of the walk. So that gets us our speed related information. Therefore, the time taken is going to be distance 1 over speed 1 plus distance 2 over speed 2. 144 plus x squared over 5 plus 30 minus x over 8. So that right there is the time equation. So in other words, describing the time this journey will take, and it's purely dependent on x, which is defined as our landing point, wherever we're going to put it. X could be 0, could be 30, anywhere in between. These are probably the hardest kinds of questions, which is why I spotted it and had a look at it as soon as possible. I don't know what it is about the yeah, go ahead.
Yeah, I've tried to solve it in a more chemistry type way.
Sure. Okay.
So, I mean, I didn't really get a logical answer, but yeah, basically I thought like if the distances, if they're equal, like
Yep.
that won't get us the most optimal value. But what if they're like they have to be equal in time, right?
They have to be equal in time. I mean, you want the addition of them to be equal, definitely. I don't think they both need to be the same value. Like as in time 1 and time 2 being the same value. I think what you want is the addition of the two. Because, for instance, we can see that x is going to impact... Well, let's have a look, right? This is linear and this is a root. So, I get that it's squared as well, so that kind of throws things a little bit out of whack, but the x probably is going to impact this portion of it more than this. So, if you're changing your x, you'll have different terms increasing or decreasing at different rates. So it's kind of hard to say they should be equalized. It's not like the rectangle, for instance, where you want to equalize length and width to get a square. I think it's going to end up being a little bit different than that.
So, yeah, that makes sense. But yeah, that's how I kind of worked it out. But yeah,
did you get an answer to work with, or?
I've got a weird answer, but yeah, can I just explain what I was thinking?
Yeah, certainly. Go ahead.
So so in chemistry, like I said, I did it in a more chemistry way. So in chemistry, we have to convert. We can't use grams. We have to convert them to moles, right?
Yep.
So yeah, and I kind of assumed that the time should be equal, and then because of that, I basically converted it to time.
Yep.
I I basically divided it by the speed, so I can record the time value. Yeah.
Yeah, you divided the distances by the times.
I
by the
guess
speed,
my
sorry.
flaw.
Yeah.
I guess the flaw in my method is that I kind of assumed that the time should be equal.
Yeah, that'd be the main thing I'd call to scrutinize there, because just doing, again, remember time being distance over speed, that's perfectly fine, and that's a great starting point to do. But yeah, assuming they'll end up being the same thing is where things are going to get a bit tougher. That's an assumption you can use for your rectangle area stuff, but not so much for this kind of thing. Just because the equations are so different, it's unlikely. In fact, it may even be the case that the times never could be the same. Because if this is stupid long and this is stupid short, it kind of doesn't really matter. There just flat out might not be a spot where they ever are equal. Now, they're not, they're kind of, one's almost more than double the other. So it could be the case that the times may or may not ever, over that same domain, be the same. But anyway, right, so we have our equation. Now that we have our equation, solving for what we need to solve is going to be not too bad now. Right, so if we're trying to minimize this value, we're just going to graph it over the domain that we have, which 0 to 30, because x is got to be somewhere between either the start or the end. So we'll graph this from 0 to 30 just to see. It should be a turning point, I would imagine, but I guess we'll find out once we graph it. Okay, so we got square root 144 plus x squared over 5 plus the 30, take x over 8. Set up our domain, 0 to 30. Let's bump this up a little. Yeah, so we get a turning point there. Can we, least possible time, it doesn't say decimal places, so we can't really use the answer we get from this, but we can at least use it to tell us that we got the right answer when we do it in our CAS instead. So we know we're aiming for, actually what are we aiming for here? So it's the x that matters here. The y is time and the x is distance. Yeah, because it's a t of x function. Cool. So we're aiming for 9.6 as our answer. If we do a quick sanity check, that means we'd be landing like there-ish. And if we look at the relative speeds, it makes sense that we're going to be dominant walking versus rowing, because walking speed is greater than rowing speed. Because, you know, if it was anything north of 15, then we would probably start worrying, because not only are we ended up traveling the hypotenuse, which is longer than any of these, and it's also through water, which would be a slower speed. So these are the things you can probably start considering when you do a quick sanity check on your answer. As for getting the exact value there, it'll just be an F min. So let's go F min and put a dome. Actually, let's see, do we need a domain? Nah, not this time. It was a global minimum. So that's the one that you would give, and you would give it in terms of hours. Sorry, this is X. What am I saying? So you give it in terms of kilometers here. Yeah, that looks good. Any questions there? These are by far the toughest, because people will maybe make the... Oh yeah, go ahead, Tyler.
I was gonna ask what section, what chapter this is.
This is chapter 12. Yeah, chapter 12,
Oh,
extended response
okay, so
section.
revision 1. Okay, so that's right.
Yeah. Yeah, that's right. But yeah, like, it's probably typical to start with your speed and distance equation, but it tends to be tough to actually create it. I found a lot of students will struggle with that. And especially something like this, where you're not even necessarily told what the path is ahead of time. Like, it goes a lot smoother if they tell you, hey, this is the path here and this is the path here, and you just got to find those variables. But when it's all written in a worded format and you're creating your own diagram, the first barrier that I find is creating that. Creating that initial assumption that it's going to land somewhere. So I guess that's one thing to consider when you start doing similar questions to this. Part B is the same, but now C is going to be a slightly closer to B. As we can see, it's really only going to change the horizontal portion here, right? Because X is still just going to be X. The hypotenuse had nothing to do with this horizontal distance beyond just the X portion of it. So only what's going to change is the 30 minus X is now going to be 24 minus X. So not much is going to change. But yeah. It looks like 15 is going to be similar. So last time we were looking at our speeds and distances, now we're looking at costs. But it's the same idea, which is you've got different costs for different portions of the journey. It costs a certain amount to go underground, it costs a certain amount to go on the surface. There's a certain speed for water, there's a certain speed for land. Right? It's the exact same idea. Where you start is going to be a bit different, because rather than thinking about your speed, distance, time equation, it's now going to be in terms of costs and maybe profit. I haven't really had a look at it yet. It's going to be a cost equation because we're trying to minimize costs. At least this time you get a picture to work with here. It costs 25 to go underground, which is going to be like this sort of 3 meter thing, and this X. All those would be considered underground. Anything underneath this horizontal line of house A. And $10 per meter for the surface. So you can see basically as long as you are staying above this line, you're considered in the surface. It's going to end up being the same sort of equation. All you got to do now is put it together. So I'll let you guys have a think about how we might do so. worth pointing out, what isn't mentioned is that the full horizontal distance from B to the house is 4. That's not actually put in the picture just yet. So let me sort that one out. I'll get an updated picture. That's a bit annoying. They've labelled both the point and the variable as x. It's not confusing at all. Okay, that's a bit more accurate to what's going on. So if we think broadly about how much this is going to cost, even without really looking at the picture, you can assume there's going to be some portion of it that's going underground and some portion of it that's going on the surface. So if we think about our costs involved, C total is going to be the cost of the underground, so CU, plus the cost of the surface, CS for surface. That's just broadly speaking what our costs are going to end up being. Cost of one plus cost of the other. Cool. That breaks things down a little bit nicer, because rather than trying to think about costs in the holistic sense, we can now think of it in terms of how much is above ground, how much is below ground. Furthermore, these costs are all going to be proportional to x, where x is going to be one of the distances here, which you can imagine splitting everything up and distributing across all the distances. You can get most of these things in terms of x. So with that in mind, our costs are proportional to x. The only question is how we're going to start filling out some of these unknowns.
We did the same way as the last question.
Yeah, same as the last question. Exactly right.
So distance between B and X.
Yep.
So that's square root of 3 squared plus x squared.
Yep. That's it. We got that distance. We got some
Plus,
other.
that's the underground distance, and plus
4
4 minus x.
minus x. That's going to get us this bit here, the overground. Underground, overground. That's exactly it. So when we start putting our, let's do these one by one. So cost of underground. So we now know that's the distance that's covered underground, and we also know the price per thing for underground, and all these are in terms of meters already. So what's our cost equation going to be for the underground portion?
We just multiplied by 25.
Yep, that's right. $25 for the underground portion, multiplied by the total meters of the underground portion.
Yep.
Perfect. Exact same thing for the surface bit. So that's going to be the $10, and it's multiplied by the 4 minus x. Oh, I didn't really specify this before. The reason this part's 4 minus x is because 4 total, and then you got this x portion of it that you're subtracting from it. So from here to here is therefore 4 minus x. Just in case anyone was still confused as to where that was. Okay, we have both of these. We're just going to add them together, right? This plus that. That's going to get us our final cost equation, which I'll start plugging into the CAS now. Function is equal to 10 bracket 4 take x plus 25 root 9 plus x squared. Okay, find the length of pipe which should be on the surface to minimize costs. It's trying to minimize costs, which seems to me like we're going to do an F-min here. Alright, this is a cost equation after all. Does that make sense? Yeah. Because if we're going to assume our origin is directly at the house, then yeah, 1.3-ish meters from the house seems about right, because it's more costly to go underground than it is to go overground. Cool. Alright. Now as far as actually answering our question though, what do we do? This isn't quite the answer just yet. It's asked us to find the length of pipe which should be on the surface to minimize costs.
Or we just do 4 minus that x value.
That's it. 4 minus this. I'm just going to do 1.3. So roughly 2.7, or I guess even better, technically what you should be doing is the exact value here. Which, yeah, okay, fair enough. Just stays out to be there. Of course, so the reason 4 minus x is because it asks specifically for this portion. What should this length be? Not what should this length be. So this has fundamentally just been the exact same question as question 14. 14 called it speeds and times. This one's called it costs and lengths. There's really no difference between them. Except I guess one is multiplication, the other was division, right? But that just comes from understanding the specific nuances of that question in particular. As for how the equation was set up, it's more or less the same thing. Okay. Did anyone spot, like, was 16, 17, were any of these worth doing? Did anyone want to have a look at these or something else? If you've got the textbook open as well, like, feel free to point and pick one out from any of there. Kind of done a few of these already. Maybe this. This feels like something weird that would show up. Basic design workshop wall, 6 equal windows. Each of those dashed lines is a length of 2 meters. Total window space is 36 meters squared. Express total area of the brickwork. Okay. So these boxes are the windows, so that would not be considered the brickwork. So everything that is not inside these rectangles is going to be considered brickwork. Okay. Makes enough sense. We need to figure out what the... oh geez, what's x? Oh, window height is now going to be x. Cool, okay. So trying to get our area in terms of the window height. Oh, because we don't know how... no, of course. What do we not know? We don't know the height of it, and we don't necessarily know the length of the windows either. We just know they are equal. Oh, we know the total area of the window, sorry. I'll let you guys have a think for a bit longer.
we can. I think we can visualize the area a bit easier if we do the windows together, like side by side. I mean, that's not how it is, but
Mhm.
yeah.
Imagine them all side
So
by side. Sure.
yeah.
Um,
So on the sides there will be like 4 meters, and on the sides will be like 2 meters from 2 meters thick, and on top it will be it'll 1.5 meters.
hang on. So do you mean like this?
No, like excluding the window part.
Oh, excluding
The
all the windows.
yeah.
So if you remove all the windows, you're left with some box.
Can I use
Where'd you get
the
the 1.5?
annotate tool? Can I use the annotate tool?
Can you use the what, sorry?
Can I use the annotate tool?
The annotate. Yeah, yeah, yeah. Go ahead.
Okay, so what I mean is like wait, that's okay. So that's like the window area,
Yep.
and that's like if we imagine it all together.
Yeah,
So
if they're all just sort of bunched up.
that's so this part will be 1.5, and this will be 2.
Why?
All of these are 2, right?
Yep. Every dash line in there is a 2. Yeah.
Yeah. And yeah, so if we just put them all together, it will, well, all the bits between the windows will like move outside.
Yeah.
Yeah, so 2 meters plus 2 meters, that's is- uh oh wait, no, so that means this will be 4.
That seems more appropriate. Yeah.
Yeah.
And then the other would be you're adding 1.5. Oh, sorry, you're adding 0.5 to both. So that's going to be now 2.5 top and bottom.
Yeah.
Oh, so hang on, no, it's 2 in the middle. Hang on. So it's 2 on top, 2 in the middle, 2 on bottom. So now you're looking at 3 on top.
Wait,
So like this bit in the middle you're cutting out is 2. So you're distributing that
oh
evenly
yeah,
top and
yeah,
bottom.
that's
So that's now 3
yeah, so
on
that's
top and bottom.
yeah, I for some reason I calculated half.
Yeah, that's fine. I get you. You're thinking of halving things, and yeah, got it.
Yeah.
Okay, fair
So,
enough. So we've
yeah.
done this now.
So like yeah, we've done questions similar to this, so
Yep.
yeah.
No, I
So
get you.
this part that's 36, and yeah, I think we can continue
Yeah, sure. Okay,
doing the rest.
cool. So fair enough. So we got 3 here. We got 4 on the outside, and a total area on the inside 36. Okay, sure. Where might we take it from here then? Because one of the things we're going to have to eventually put in there is the x, right, which is the window height. So by merging them all together, we do have to still factor in what's happened to x off of this. If we assume they all just sort of, merge into the center, then we can say the height of what our thing is effectively doubled what it was initially. So rather than x now being the height of our window, we now have 2x, I guess you could say. So like this portion of our merged bundle is 2x.
Yeah, so the total height would be a 6 plus 2x.
Yeah, so from like absolute top to absolute bottom of the brickwork thing that we have, yeah. So height of brick is now 6 plus 2x. Sure. It's looking alright. Yeah. We got some initial values in there, we got our x in there.
So if 36 is the area, then the width will be 36 divided by 2x.
Yeah, because you're starting with your, that's good, area being length by width. If you know area is 36 and the, I guess we'll say length is the 2x, then you're dividing to get your width. That's it. So let me redraw this a little bit. We've now got from here to here is the 36 over 2x. Nice. It's looking strong.
We can do the same with the width as well. So 8 plus 36 over 2x, which is 18 over x.
Yeah, good point. Put a double equal sign there. Nice. Yeah, so you got the total, yeah, again, the 8 coming from the two 4s on either side. So yeah, what you've effectively now got is the full outer rectangle. Nice. Got the width of the rectangle, got the height of the rectangle. Where are we going to go
So
from
we
here?
can just multiply the length and the width.
Yep, to get the
total
area of the full thing. Yep, area,
Yeah.
brickwork. I guess I should say area total, but yeah, anyway. Area is going to be WB times HB, so 6 plus 2x multiplied by 8 plus 18 over x. That's our big total area there. Nice. Is that the final answer though?
This looks to be, we're doing A, right?
We're doing A, yeah. So A being in the brickwork. I will say, I think the intention is that the brickwork is supposed to exclude the windows.
Right, so are we finding the total area of the brickwork?
Yeah, so it says express total area of the brickwork, not the whole fixture as a whole, right? Because there's no actual bricks in that window, right? The window's replacing bricks at that spot. So what you've got here is the, I've kind of mislabeled it by calling it area of brickwork. It should technically be area of the total fixture as a whole. So if we want to convert that to now specifically the brickwork portion, we got to do something, which is what?
Minus 36.
Minus the 36 that existed in the window. That's it. The combined window. And that's exactly it. Yeah, that's perfectly fine. It's a nice little solution set you got there, which is breaking them all down into a single, I guess merging them all into a single big window and then just distributing the remaining lengths and widths however you see fit. You don't necessarily have to merge them all inside. You can arrange them technically however you want, but it's just going to make it a bit harder to do it any other way. Yeah, I like this approach. Now, as far as like presenting your answer, yeah, you might want to like expand it out or something like that because this isn't technically fully factorized now that we have the minus 36. But this being a tech active, it takes no effort to now put that in a CAS and just tell it to expand. We're going to have to put it in a CAS anyway to sketch the graph. I'll work on that. In the meantime, part C, finding the dimensions of each window. So have a think about how we might use what we've got to minimize brickwork.
And can't we just use fmin with the function to for number C?
Yeah, we're looking for a minimum amount of brickwork, so fmin seems like a really good idea here, yeah. Yeah, fmin, do we need to put a domain? Let me get a graph of this first, just in case. Because we're definitely going to need at least to only consider positive values. But let's just have a look and see, just in case. Oh geez, what's this going to be? What is this graph? This graph is, if you multiply all that through, it's a linear? Actually, I can figure that out quickly. Just print h of x. Surely it'll expand it for me. Okay, it's a very weird graph. Good old reliable. It's going to do it. Oh, it's kind of hyperbola. So an fmin is probably going to find like that thing there. Fmin function comma x, and we're just going to say x is positive so it doesn't hit that other side of the hyperbola. Okay, does that make enough sense to have an x of 2.4-ish? Well, if x is supposed to be the height of the window, yeah, based on our picture that could be pretty reasonable, I suppose. Cool. Okay, so we have this initial x value here. And we're gonna, let me just convert it down onto here so we don't have to look at two separate things. So x is root 6, and if we care, it's also roughly 2.449. Okay, we've got our x. What does that now mean that we can start doing to answer our part C?
All the windows together is 36 square meters.
Yep.
So 6 of them will be 6 square meters each.
Yep. Area of each individual
And
one.
as we know the height is square root of 6, you can just divide 6 with the square root of 6, which is square root of 6.
Yeah, that's right. So you're basically going back
So,
to the whole, this thing here, area being length by width. You're now putting a 6 there, and you're putting the, where is it, root 6 for the width bit. So a equal, oh, hang on, that was already there before. Root 6 w, 6 over root 6. Yeah, that'll be it. That'll get us our full dimensions there. Right, that's what I asked for. Find dimensions of each window. Yeah, that'll be it. I guess defining them properly, making sure that you're saying which one's the width and which one's the height. That might matter, but dimensions, you should be able to just sort of get over saying like x by x, right? Just like any other shop would tell you. So width of that being 6 over root 6. You'd probably also want to just chuck that in the cas real quick or otherwise to rationalize the denominator, because that's technically what you would typically do. In fact, this one, because you're dividing by the root of itself, it does actually just come out to be root 6 as well. So is anyone shocked that we now have both equal length and width in this case? Turning all the rectangles into squares seems like a very consistent thing that keeps happening in these, whether you're maxing or minning, I guess. Interesting. Anyway, that's more or less what we've got time for there. So, are there any questions about what's been covered so far? We are looking at the hardest questions, so it makes sense that these will take a bit longer to get through. Do we have anything that needs to be clarified? All good? Sweet. Just because you guys are still here, you might as well finish off the Part D right after the call. So if building regulations require that both the height of and the width must be not less than 1 meter, find the maximum amount of brickwork that can be used. So now we're trying to, I guess that kind of sounds like the same thing, doesn't it? We're maximizing brickwork. But now it's a little bit different because the height and width cannot be less than 1 meter. And haven't we already got that? This might take a bit more reading into to try and figure out. But have a go at that. There's a nice little bit, very quick extension work there. And yeah, feel free to message me if you have any questions about finishing that one, or even if you've got like SAC related stuff. Happy to try and do that as well, because by Friday, obviously, you guys won't be able to do any more SAC stuff if you're already doing it this week. You guys are doing it this week, yeah?
Was in a SAC.
Yeah.
I think mine's on the 15th.
Yours is later? Okay. Cool. Alright, well, I'll leave you guys to it. Thanks for coming.
Thanks, Chris.
Thanks. Have a good day.
You too. Take care.